Alright, ladies and gentlemen, welcome to Forces 2, Lesson 2.2. That is, what is acceleration and how I calculate it. In review, our formula for acceleration is our final velocity, which we call FV, minus our original velocity, which is OV, over time, which we're going to label as T. And so we're going to learn how to use this formula as well as figuring out what the label is for our problem in our acceleration formula. Okay, so our first example problem is this. Rupert was biking down a hill at a velocity of 10 miles per hour west. When he got to the bottom of the hill in 5 minutes, his velocity was 25 miles per hour west. And so we need to find these three variables, the FV, which I'm going to label in green, and then the OV, which I'm going to label in blue, and then the time, which I'll label in pink. And so we're going to find those in our formula right now, in our word problem. And so I'm going to find the original velocity. That's the one I start out with. So Rupert started out at 10 miles per hour west. And so I'm going to actually label that and circle it in blue. And we're going to put that as OV. So we're going to put 10 here. And then I'm going to find my final velocity, which was 25 miles per hour. And then our time was 5 minutes. And so I end up with 25 minus 10 divided by 5. And so I want to actually do the top first. And so if I do 25 minus 10, I'm going to end up with 15 divided by 5. Okay, and so what that gives me is a simple division problem, and I get an acceleration of 3. Well, 3 what? Well, let's take a look at our velocity label. It is miles per hour west, and so it's 3 miles per hour, but it changed every minute. And so it's 5 miles per hour per minute, and our direction is west. Our next problem, Stuart was racing up a long hill. At the bottom of the hill, he was running at a rate of 8 meters per second west. At the top of the hill, he was running at a rate of 2 meters per second west. It took him 3 minutes to climb to the top of the hill. And so we're again going to find our parts there. And so our FV is going to be blue, our OV is in green, our time is going to be in T. So I'm going to find my original velocity first. That's what we started out at. At the bottom of the hill, he was running at a rate of 8 miles per hour west. That's going to be our OV. So I'm going to put that 8 here. Next, it is our time that we're going to find our final velocity, which is here. And then I'm going to end up with my time, which is 3 minutes. Okay? So we do our division last. We still do this at the top first. We're going to put that together and simplify. And 2 minus 8, that's going to give me a negative 6 divided by 3. It is so important, and a lot of you guys are going to do this, is that you're going to say, okay, 2 minus 8, that can't be right. Let's do 8 minus 2. And you would be not faulted in doing that, except the fact is that what is our final velocity and what is our original velocity? We must have them in the correct order. Please try to get over that. You must put that in, or else we won't know if we are decelerating, which is a negative value, or accelerating, which is a positive value. In this case, we are slowing down. It's important to know that because at the top of the hill, he was running slower than when he was at the bottom. And so we're going to be decelerating. And so it's negative 6 divided by 3. And so he was decelerating at a rate of negative 6 divided by 3 is negative 2. And my label is in meters per second. And since my time is in minutes again, it'd be minutes. And then I'm actually going to put my direction on the second line, west, because I ran out of space. And so This would actually be all the way over here after the minute, but it's always important to have the labels all together. 2 meters per second per minute. And so to recap, if I wanted to find acceleration, I need to remember FV minus OV divided by time. And I always need to think order matters when I'm doing this. Because if the order is changed up, you won't know if it's a positive value or a negative value, and that'll tell us whether or not we are speeding up or slowing down. So order matters. Make sure that you do not mix these two up, the final velocity and the original. You must always put them in the order that you see in the formula. With that, you can practice the rest of the problems in your lab, and then you should understand how to calculate acceleration.